So,
Yes, sir.
so last week we saw about how the planets are formed, how things are moving around in space, how are things forming into different elements across the sky. So today we are going to see a little more about where we left off. And we are going to see a little more about the star. In particular, we are going to see about the neutron star. What is neutron star? How are things happening in neutron star and all these things. So we saw about what is astrochemistry, what is Big Bang theory, what are the formation of a planets, so on and so forth. So that's for the last week. So what did we see? We saw that what were the ways in which a planet can be formed, what is about astrochemistry, what are the seven governing laws of dynamics, that is planetary dynamics, and we saw what is physics, or how are the classifications of physics, cosmology, astronomy, biology, chemistry, and when you add physics every day it becomes astrophysics, astrochemistry, astrobiology, astro of everything. And over many billions of years, say like when the planets did not exist, there were only some round blob things, like they were floating around in space, and these were all the effect of when the astrochemistry came into being. That is, when you think, it is all related to the Big Bang. The Big Bang is all that questions everything. So who you are, what you are, where you come from, what's for lunch, all these questions come from the stars that are long gone. So that is the Big Bang theory. So we saw about every other astronomical object. We saw where the planets could be, how are their orbits, what are they made up of, how is a protoplanet. That is, before there existed a planet, there used to be something called a protoplanet. Okay, I will give you one more example. What came first, the chicken or the egg?
Both.
Okay,
The chicken.
the chicken. What about the egg?
Um, the hen lays the egg.
Okay.
So
Okay,
From
even
the egg only the hen comes.
okay, even still, if you keep talking about it, you will always end up with finding that there is no egg, no chicken. It will always overlap with each other. So the first thing that came was not an egg, not a chicken. It was called a proto chicken. That is, even before chicken existed, there used to be some other kind of chicken which had created that egg. Is black hole a dead star? Mm, yes, and also no. There are two ways in which a black hole can be formed. We are going to touch upon it here today also, because since neutron stars also can also give black hole its own life. So we are going to see how it is also forming. So we saw all the ways in which a planet can get its all its elements, and how are things that are left out, those that become comets will float around in the sky. So this is the way in which the disk, that is dust, rock, planetesimal embryo, and finally it becomes a planet. It's a round shaped planet will form. So when you think about it, this planetesimal, that is even before the planet existed, there used to be a round kind of thing that is floating around in the sky. That is also a part of a star. So if star can create planets, so where did that star come from? That star has to have some life, right? So all these things we ask as a question, whether there was something even before nebulae, even before Big Bang. What are things there? So first thing we are going to get answer today is, what is a neutron star? Because when you ask people in astronomy, when you talk to scientists, they always say there has to be a reason which came first. Before chicken, before egg, there was a proto chicken, and before star, before black hole, there has to be some other kind of star. So can it be a neutron star? Can it be any other kind of star? That's what we are going to see today. So, so when we started this session, some 15-20 episodes before, there used to be a session called "Where is the Milky Way?" So in which we got the address that from Earth we can go to the solar system, and then we go to the Milky Way galaxy. From all the way out of our solar system, we can see the Milky Way galaxy, and this Milky Way galaxy is not like very small thing. It has consisted of so much, so many amount of stars, and our sun is also one part of that star. So what better way we'll recollect what we have seen about a star, because we are going to compare something with our sun to another star that is going to be neutron star. Why it comes, I'm going to tell you. So we are going to wear some glasses. We are going to revise what is the life of a star. So a star's life forms from a nebula, a cloud of nebulae, which is again forming from a supernova event. That supernova will give a nebula, and from that nebula, it goes from a sun, it becomes a red giant, it becomes a planetary nebula, it becomes a very overlapping, very distantly moving kind of gas, and then it becomes either a white dwarf or another star forming nebula. This goes on and on. But there is also another way where a massive star can form, and that massive star becomes a red supergiant, and from that supernova, it can either become a neutron star or a black hole. So that is what we are going to see today. So from the birth of a star, we can know there are so many things of happening inside. So from a nebula, it becomes a star cloud, and that star cloud becomes a young birth of a star, so becomes a protostar, and that it becomes a main sequence star. Our sun is a main sequence star. So it is now in a middle age, and it is going to be there for the next 5 billion years. Next, after that, it becomes a red giant. It will eat all the inner planets. It will become a very fat kind of a person, and that fat red giant will become either a white dwarf, that is in a distant future, or it can either become, if some other star comes and hits us, or it becomes a very big thing, it becomes a massive star. Massive star can also become a supernova. So these are all supernovas. And finally, it can either become a black hole. We saw what is a black hole last time, or it can become a neutron star. Now, we keep on telling what is a neutron star, what is a neutron star. Can anyone tell me what does neutron mean?
Neutron is a particle of atom.
Very good, super. What other particles of atom are there?
Uh,
Anyone can tell? No idea. I know this is too advanced, but when you talk about atom, what is the most smallest thing in an atom?
Proton.
Good. I was telling you. So before this, I showed you something called as a protostar. Okay, Proto means very small. It's a very
Proton.
it's a very baby even smaller baby star. So like that, the most smallest thing that can be seen in any atom is called as a proton. But it is a very dense thing. It is a very small thing, but it has an ability to spin very fast. So protons can spin much faster, and if they emit some kind of radio waves or radio emissions, it becomes a pulsar that we are going to see after some time. So all these things, so blue, yellow and red becomes a different kinds of temperature. So what is the color of a neutron star?
Blue, the hottest.
Yeah, so it is a very hot star. So blue is something that gives so much of radiation. So we can observe so much amount of gamma radiation that is coming from a blue neutron star. So this is comparatively different types of stars. So the Rigel is a massive neutron star as compared to our sun, and this gives up so much amount of heat than anything that is compared to other stars. So our sun is consisting of so much of things. So we can see, we can have a core, radiation zone, tacho line, convection zone. All these things are ways where the hydrogen atom and helium atom will combine, and when they get compressed, they get out into the radiation and they come out in the form of light. So this is how they make energy. So they cook hydrogen and helium. So they keep on cooking hydrogen to make helium, and that helium comes out and becomes a burnt gas. So I told you about nuclear fusion, that is joining of atoms, four hydrogen atoms to form one heavier helium atom. So this is always happening. This continuously happens over so many millions and billions of years. So that we get light. So hydrogen becomes helium, and from that helium it becomes oxygen, carbon, and nitrogen. So our star is right now at the age of a main sequence star. That is in this, it is in the adulthood. After another billion years, it can either become a middle-aged star, and after another 3 billion years, it becomes a white dwarf. So this is all in relation to the one on your left side. That is a sun-like star can become. Did sun form from a nebula? Yes, obviously it came from a nebula. So it is a star cluster. Our sun is forming at the Sagittarius arm of a Milky Way galaxy. So this Milky Way galaxy had a very long arm. That is what you call as an arm is a long tail like thing which has got all the clouds of nebula. From that one nebula, we formed into a star. We also have our brothers and sisters. We call them as Centauri. So Alpha Centauri, Proxima Centauri, all these stars came out of that one particular Sagittarius arm that was once upon a time it was a nebula. So this is our left side story. What about our right side story? So we have massive star. So it becomes red supergiant. So it becomes supernova. It becomes neutron star or a black hole. So we are going to see what is a neutron star. So how did it come? So from a massive star, even before it goes back into the state of a supernova, it has to become either a neutron star or a black hole. That's how it is. So it happens very fast. So from helium, carbon, oxygen, neon, magnesium, every other element will form, and when they get compressed and tighter, it becomes a very tightly, densely packed neutron star. So this is how a massive star will start to make its own elements. So just before it becomes a supernova, it has got iron, silicon, magnesium, neon, oxygen, carbon, helium, hydrogen, and all the outside becomes non-burning hydrogen. So where do you find iron?
in our blood.
Very good. Where do you find silicon?
Yeah.
Silicon is found in
See,
silicon is found in so many electronic devices.
silicon chips.
Ah,
Yes,
gel.
yes, very good. Also in that. And magnesium, have you ever seen magnesium?
Yes.
Where is magnesium coming from?
Magnesium
Silicone
is found on land.
like rubber gloves and all.
Oh, very good, super. So magnesium is kind of
Rubber gloves and sometimes it's also used to make decoration for bags and all.
very good, super. Okay, so it is a kind of
And also
magnesium. Magnesium is used like a fuel, and it can be added as an additive for making so many things. Oxygen, where is oxygen found?
It is found everywhere on Earth.
Okay, so we can breathe oxygen also. So we
and
are
it comes from trees.
we also are made up of a lot of carbon based things. So the clothes we wear, the bones we have, all these things have carbon. So helium and hydrogen, it's a gas form. So this is a massive star. So compared to our sun like star, a massive star has so much amount of elements. So what happens? So when it collapses, so it is kind of like a death of a star. So after a star has all its massive stars, super red giant, it has to become a very tightly packed dense star. And this neutron star was first discovered by Jocelyn Bell. She is a research scientist based out of America, and she discovered the first remnant traces of a neutron star. How did she find? She used general physics mathematics to find that whatever that comes from inside of this particular star has so much amount of gamma radiation. So gamma radiation can only be brought by hitting, that is, when you hit a proton with an electron, the neutrons that come out free into the outside of that atom becomes a free neutron. So this neutron has to be absorbed by something. What is better way of absorbing this? Through radiation. So all the gamma rays, all the x-rays, all the high energy radiations that come from a neutron star are made up of neutron atoms. So this is how a thing that was first discovered by Jocelyn Bell. She used a radio telescope to discover that there is some kind of high energy radiation that is coming from deep inside our entire universe. So what are they otherwise called? They are also called as pulsars. When they have a spinning radius, when they spin very fast at the same space, it becomes pulsar. Sometimes their beam can target a planet or another star, and they can break that planet itself. That's a very powerful amount of radiation that can break a planet. There are also magnetars, which can have very high energy magnetic fields, but they decay in a very long duration of time. So this long duration magnetic fields can also emit a lot of X-rays and gamma rays. So as I told you, it's a very dangerous place to live when you are very close to a neutron star. So this is how it is made up of. We saw that our sun is made up of so much of from the nuclei, all the heavier elements will fall in, and all the outer sides is made up of hydrogen and helium gases. But inside, it is completely devoid of all the elements. So only electrons, ions, and neutrons are there. So it is a very highly compressed, tightly packed. So only very small amount, that is just above the atmosphere, there is a thin layer of hydrogen and helium carbon atoms that is floating there in the outside, which is keeping it in the shape of blue. So the color of a neutron star is brought by the amount of light that is passing slightly through the hydrogen and helium gas. That is the color why it is called as blue. So we know what is a neutron star, we know what is a black hole. What happens when they both combine together? What will be the consequences of it? So this is right now a neutron star, and that is a black hole. What happens?
Mm, that forms into a nebula.
Almost there, but not a nebulae.
They form a supernova.
No.
It forms into a planet?
No. Okay, no guesses, no problem. So what happens when two things collide? That is, two stars combine. That is, a normal range star and another normal range star, or a sun-like star. Two stars, sun-like stars combine. There becomes a very slow-moving star. It becomes a Stagler star. It becomes a blue neutron Stagler star. But if it is a very fast-moving star, if it hits in a very high speed, nothing will survive, everything will become a hydrogen gas. But if a star, that is a neutron star, a normal star, or a massive star, hits a black hole, there is a lot of material that is pulled into the black hole's side. It calls an accretion disk. So it becomes in the shape of a spaceship. It forms into the shape of a spaceship. So you can see this is now looking like a spaceship. So it has a black top, it looks like a hat on the side, so it is spinning at the same pace. This is what it will become. So this black hole, if it is very super massive, it can become such kind of a thing which is visible in a different form of light. So scientists have observed this happening, very common. So if a neutron star is very close to a black hole, this is the possibility in which it will die.
It looks like Saturn.
It looks
Yes,
like
sir.
it looks like Saturn, Kanama, but when you compare it to the size of a planet, it is like billions and billions of kilometers wide. So it is a massive Saturn. If you can compare it to a Saturn, it is a massive Saturn. So we know how long it will take for things to change from one star into another star. So from normal star to a middle-aged star to a red giant to a white dwarf to back to a supernova. All this takes some time. But how long does a neutron star live? If nobody disturbs a neutron star, if it is a very, or you know what is a rogue, that is, it doesn't obey any law, any close planet doesn't revolve around a neutron star. If it is going around freely in the entire universe like la 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 la, if it keeps on going, what will happen to it? Will it live or will it die?
Uh, it will live
It will live for how long?
for billions of years.
It is something which theoretical physics cannot understand. So they imagine that if a neutron star can have a free space, that it doesn't have to any bother any other star, it will keep on living. It will never even die, because the process of a neutron formation from a atom to a proton to neutron, everything will keep on going forever and forever and forever and forever, ever forever. But like our sun, we have some limited time. So 10 billion years we will die. Red giant, 1 billion years it will die. For a red dwarf, 1 trillion years it will die. White dwarf, 10 to the power 34 years it will die. 100 to 100 power years, black holes will die. But a neutron star will never even die. It will always be there if it is very alone. If it is very close to something else, if a neutron star comes close to a red dwarf, it can die. Neutron star comes close to a black hole, it can die. Or otherwise, it will never even die. So, this nearest neutron star, so you can ask, sir, what happens if we are very close to a neutron star? What will happen to our Earth? So there is no chance. We don't have any neutron stars very close to our because our the place in our Milky Way galaxy is a very safe place. We are in a very distant arm of the Sagittarius arm. So for another thousands and thousands and thousands of billions of years, no neutron star can come form near us. So when you compare it, you can see lots of one same thing in our entire galaxy. That is, we have got pulsars, supernova remnants, pulsar wind nebulae. That is combination of both pulsar and a nebulae. And all these things, when you look, it becomes an interstellar material. That is what we can see every day. So the first observed form of supernova and a formation of neutron star was in the year 1054. That is about 2000 years, sorry, 1000 years before. That was the first time when they noted down in China. So called Crab Nebula's first supernova event. And after that, in the year 1572, there was another Tycho's supernova, which observed was the first time where a human eye can observe 7 different supernovas happening at a period of 500 days. That is from January of 1572 to October or November of 1573. So all these times we were observing a supernova event which had recorded so much amount of neutron star activity also. So why did they choose this particular time to study? Because they were the first times they were seeing a pulsar, that is blinking light that comes and hits us all the time. So how does a pulsar look? So this is how a pulsar look. So it keeps wobbling at the same space. Sometimes it has a very high powerful gamma radiation of light that can hit us, and that light is enough to see one bright sun at the middle of the night. That is the amount of light that you can see. It's a very bright star. That's a pulsar. So this is the question that we are going to leave with for today. So we are going to see what are the different types of neutron stars. I told you about magnetars. I told about pulsars. What other types of neutron stars are there? That's what we are going to see in the next week. So that is to be continued. So we saw what is the life of a massive star compared to our sun. What is the life of a massive star? So how are neutron stars interior made up of? When was they discovered, and how significant is it to know about the neutron star? Because we have to be very safe in our solar system. So that's it for today. If you have any questions, you can ask me.
Sir, does every star have a solar system?
Does every star have its own solar system? Yes, as well as no. See, compared to our solar system, we are very lucky. We are very lucky in our space. We live in a space called as the Goldilocks zone. You know, there is a uh, three bears and a Goldilocks. Have you heard the story?
Yes, sir.
Okay, so that Goldilocks goes and sits in the chair. Mama bear, Papa bear, baby bear. Everyone will think that it is the very safe place to live. But after some time, in that house, uh, an older bear will come and say, "There is someone sitting in my chair." So that is the safe place for us to stay. Unless until we are getting disturbed by a big bear or a very big massive star, we are not to worry about. Like that, every other star family or star system that we have observed used to have a very small problem. That is, they don't stay very close to the sun, or they are too far away from the sun, meaning the life in which we are living right now is very lucky. If I myself, Nitin, Lakshya, Nitika, and Samyukta all live in a planet, we are all safe. But what if one of us get thrown out of the planet? Nitin, you want to escape out of Earth? No? No? Okay. So like that, every other planet is now holding on to its life with a big star.
How did names like nebulae, black hole, and all form?
Okay, good question. So when scientists had this thought, they had a reason to believe that after the year 1920, that is the year where International Astronomical Union formed. So they thought we should give them uh, a neutral name. That is, they don't have to have any other Greek gods, Roman gods name. You know what are the planet names name made of? You remember?
Yes.
Mars is made up of god of war. Uh, uh, Neptune is made up of god of water. Mercury is a messenger god.
The
God is
god of
freedom.
the world.
Yes, Pluto's god of underworld. So this, like this, so much of politics was happening in the astronomical body. So what they said, we don't have to worry about all these things. We will stop using these silly names. We'll stop using the silly god names, and we will have a vote. We'll vote for each name. So every year, after 1920, they had an astronomical union. They will vote for the name of a new planetary body. So like that, black hole was the name given by um, there was a famous scientist. I forgot his name. So black hole, nebulae, and pulsar, quasar, magnetar. All these things are scientific names given by scientists every year. They'll raise their hands. Everybody who is in favor of neutron, raise your hand. Like that, when they raise their hand, it becomes a naming for that particular object. Did I answer it right? Okay. So who gave you the name Litika?
My father.
Okay, so your father took the vote with your grandmother, grandfather, great grandfather, everybody, and they decided to name you Litika. So that is like how nebula and black hole got their names. Okay,
I really want to go to space.
you will. If you try and make your achievement in good in science and mathematics, then you can go to space. Every year there is a competition by uh, few international astronomical companies, say like SpaceX, Blue Origin, and many other companies like Boeing, Airbus. All these companies take a competition with all the young students and young children, and they will ask them to get themselves trained in the astronomical studies like physics, chemistry, mathematics, science, and everything. After that, if you are much more interested, you will be sent in as a special scientist and you can go. Yes, Lakshya.
How many solar systems are there, sir?
How many solar systems are there?
That's uncountable, sir.
That is like asking. Are you asking in our Milky Way galaxy or in our observable universe?
In the Milky Way galaxy.
In the Milky Way galaxy, if you ask me, they have recently discovered close to around 90 planets, 90 Earth-like planets. Okay, you know what is an Earth-like planet? I told you the name for it. Can anyone tell me what is the name of it? After you sneeze. Okay. What's the name of an Earth-like planet? Okay, you don't know. It's called an exoplanet. Okay. So there are somewhere around 89 to 90 known exoplanets. So these exoplanets are supposed to have the conditions of a solar system. So observably, we know about 90 different solar systems are there in our Milky Way galaxy. That's the easiest answer to give, but practically it is not so. We don't know the actual number. So there may be even thousands, there may be even billions, but we observed only around 90 planets to have this tendency of being an Earth like planet. Yes, Samita.
Sir, how far if you are from sun we will burn, sir?
How far are we from sun we will burn? Mm, when we are almost in the orbit of Mercury. If we are in the orbit of Mercury, we will be roasted like a chicken or a marshmallow or whatever you consider it as. So Mercury has the highest surface temperature compared to other planets. So the orbit of Mercury is
So
the
Venus is the hottest.
oh, the surface temperature. I meant to say without even any atmosphere. With atmosphere, Venus is hotter, but in the proximity of the entire planetary bodies, Mercury is having a stable atmosphere, stable temperature of always at 300 degrees Celsius. Venus is fluctuating. Venus has sometimes it goes beyond that because it has high energy radiation due to sulfuric acid rains and so many things. You will not burn in Venus. You will become like a sambar or a dough. You kind of become like a soup in uh, Venus atmosphere. But in Mercury, if you stand on the same side, you will instantly become a roasted chicken. Yes, yes, sir.
So for each Earth, there's like one moon. That means for 90 Earths, how many moons will be there?
Okay, exoplanets, exomoons. Okay, mm, I'm not sure of the correct number for it, but so imagine we are still trying to understand all this exoplanet theory by only observing them. We have never sent any spacecraft. We have never received any information saying that, hey, I am Kepler 36b and this is my planet and this is my map, so have this. So nobody knows what is happening in Kepler 36b. Okay, so if maybe another 20-30 years somebody says hi from another planet, we will be the first people to know. Until then, we don't know what is the actual number of moons in another planet.
When will Pluto be nearest to Earth?
When Pluto will be nearest to Earth, its orbit is around 220 close years. 220 or 280, I don't know. So somewhere around 200 plus years. If we consider this as the right time, so we had the closest proximal orbital position at the year 2015. The same position it will come back again in the year 2200 something, that is 2220 or 30 or 2240 or 50. So another 200 years we will not be very close to Pluto will be very far away from us, and it takes around 17 years to reach Pluto if you start now. Every year after that it will become twice, thrice, or even more than that, because Pluto is the farthest one in our entire solar system.
One astronomical unit is equal to how much kilometer?
I'm not sure of the exact number, but it is the distance between the sun and our Earth. So I don't know. I can able to Google it, but that will be like cheating you. So one astronomical unit is the distance between the Earth's orbital position to the sun's orbital position at the closest point.
Is every planet's orbit different?
Yes, they will have a different elliptical orbits. The one with the most spherical orbit is Mercury. All the other planets have a kind of elongated elliptical orbit. So they have shorter times when they are close to the apogee, perigee. It's an ecliptial term. So if you read about orbital motions, most of the planets, apart from Pluto and Mercury, everything is slightly elongated, so slightly longer. Most longest one is obviously Pluto, and the most shortest one is obviously Mercury. Okay. Anything else?
Is time different in space?
I think I told you already. So time is a relative thing when you compare it between us and a larger object. So we are very fortunate because we have our big brother sun always rotating us. So right now, Lakshia's window is showing a, I think almost it's a morning time, correct? What time is it?
8:49.
49. So we are right now in the dark side of the earth. That is, we are in the time between 6:20. So each time we are having to check our time, we are comparing the light from the nearest star and we are comparing our time dependent to it. There is no such thing as universal time. So if there existed a universal time, we will be somewhere around 5 billion years into the space. So time is different for
What
everything.
will be the time now in Mercury?
Mercury has the very shortest spin rate, so it is 53 days to complete one year. So that means it can go around 3 times to finish one day. So I think it'll be when you're standing on the front side of the Mercury right now, it will be somewhere like 12 a.m. But if you are on the other side of the Mercury, it will be like uh, 12 o'clock in the night for at least 53 days. 53 days once it'll make a small spin. After 53 days, it'll show its other side, show its other side, show its other side, show its other side. 53 into 3.
So 53 days is the one day in Mercury.
Yes. Nitin, you are very bored, huh? You are very bored. Did you hear about Perseverance and its small helicopter, Ingenuity? What is happening now? Why is it not flying? It's still getting late. We are already late by 1 month. You know why? Any guess?
COVID.
It's not COVID. Nitin, what do you
It
guess?
was
It is?
the weather was bad.
No, not weather. It is not weather. They are still testing some telemetrics. That is, the right time to fly is different for us and Mars. So they are testing it, and maybe possibly after 14th or 14th of April, they are going to fly it. They are going to try it one more time. What it's going to do is it's going to rise for 10 feet, take photographs from the height of 10 feet of Perseverance rover, then slowly coming back and sitting that spot again. So it is going to do it for 3 times. Go up, take photo, come down. Go up, take photo, come down. Go up, take photo, come down. It's going to do 3 times. So, okay. So that's it for today. You all have a great week. So next week we are going to see what are the different types of neutron stars. Okay. Bye bye.
Bye, sir. No homework.
No homeworks. Enjoy.
Sir, can you give homeworks at next week?
Want homeworks? Okay, I'll try to give. But if you are interested, you can read more about uh, orbits, planetary orbits. Read about eclipse, apogee, perigee. What is? How do you draw an eclipse using two threads and one pencil, one needle? Try to draw an ellipse with cardboard, two
Sir,
pins.
you have sent me the link now, sir. I will try to study about that.
Okay, I'll send you. Super. Done.
Thank you, sir.
Bye bye. Bye bye, Lakshya.
Bye.